Hi, this is our first video on complex numbers, and so just as an introduction, I'll do a bit more in class as well, but basically so far you've only known about real numbers, and real numbers are everything that you've seen before, so it includes whole numbers, fractions, decimals, all these sorts of things, irrational numbers, that sort of thing. These are all real numbers, and up until now this has been all okay and you've been happy with this, but in fact numbers actually are much bigger than real numbers, and they involve complex numbers. And where complex numbers come from is the solutions to equations like x plus 1 equals 0 and stuff like that. And if you tried to solve this, then you'd get funny things. If you move that 1 over to the next side, you get x squared equals -1, and to solve that, then you'd get x equals the square root of -1. And if you did this up until now, you'd go, there's no solution. But in fact, the better way to say that is that there's no real solution to this, because there's no real answer to this. But in fact, what mathematicians decided a couple of hundred years ago is that, well, we can't just stop here, because I'm just going to write don't stop. We don't want to stop here, because actually this sort of equation does actually come up in engineering and science, electronics and things like that. We do actually have this situation where we actually need to just not stop. We need to keep going so that we can actually solve these problems and come back and give a real answer to these situations. If we stop, then just because we don't know what the square root of -1 is doesn't mean we have to stop. We're able to keep going with our maths and to come back in at a real point and still solve these things. So it's really important. And so what they said is that they said, well, what we're going to have is we're going to say that the square root of -1, we're going to just call that, instead of writing the square root of -1 all the time, we're just going to call that I, and that's our imaginary number. Don't know what it is, we don't understand what the square root of -1 is, but we're just going to call this I an imaginary number. So this is the cornerstone of complex algebra, where I is equal to the square root of -1. Okay, so let's just have a look at some different things. So a complex number can be written like something like this, or -1 minus 3i, something like this. This is what they look like. And what we have here is we have our real part here. So that's real, this -1, that's real. And we've got those. But what we've also got is this here is our imaginary part. Okay, so that there and this here, they're our imaginary parts. And so this is what complex numbers look like. And they've got a real part and imaginary part. Let's just have a look at some examples. Let's just have a look at the square root of -7. Okay, you know from your surds work that the square root of -7, we can break that up into two parts. We can break that up into the square root of 7 times the square root of -1. Okay, that's just like your surds. And so what that is that's the square root of -7. What's the square root of -1? That's I. So that's just equal to the square root of 7i times I, but we don't bother writing the times. Okay, similarly, what would the square root of -16 be? Well, that's the square root of 16 times the square root of -1, and so that is, I'll just write the square root of 16i, but the square root of 16 is 4, so that's just 4i. Okay, so it's just about dealing with these numbers, and we come up with these imaginary numbers here. Okay, fantastic. What some other sort of workings? What would 3 times the square root of -25 plus 2i, what would that be equal to? Alright, let's have a look at it. That means 3 times, let's break this -25 up into two pieces. That will be the square root of 25 times the square root of -1. Okay, and then we've got that plus 2i there. Okay, so just breaking that up into two pieces equals 3. What's the square root of 25? That's 5. So 3 times 5, that's 15. What's the square root of -1? That's I. plus 2i, which is equal to 17i. Okay, so just simplifying using the fact that the square root of -1 is equal to I. That's our important part. That's how we simplify using these. Okay, and like I said before, if we've got some number z, which is a plus bi, okay, we said before that that is the real part, that a is the real part, and that b is the imaginary part. Oops, is the imaginary part there. Okay, so how we write that is if we write the real part of z, okay, the real part of z is equal to a. That's the real part. The imaginary part of z is b. It's just a number. It's not bi. No, it's not bi. It's just b. b is the imaginary part of z. Okay. So an example of that is let z be equal to 3 minus 2i. What's the real part of z? Well, the real part of z is 3. What's the imaginary part of z? Is -2. Okay, so we're talking about the real piece, and the imaginary piece is -2. So that's quite nice and simple there. So there is our definition of if you've got z, a plus bi. A is the real part, b is the imaginary part. Okay, awesome. Let's just look at equality. When do we have two imaginary numbers equal? Well, if you have a z1 as a plus bi, very messy today, and a z2 as c plus di, then z1 is equal to z2, so two numbers are equal if and only if the real parts are the same, if a is equal to c, and if the imaginary parts are the same, so b is equal to d. That's the only time those two numbers can be equal. Okay, and so let's just have a look at an example of that. Okay, I'll just do a sort of nasty example. 2x plus 3 plus 8i is equal to -1 plus 2 minus 3y. Okay, so we want to solve for x and y here. Okay, for x and y. So let's just have a look. And basically, when you've got an equality here, we've got an equal sign. So what we can say is look at the real parts and the imaginary parts. Okay, what's the real part on this side? That is the real part there. Okay, what's the real part on this right hand side? Well, that is the real part there. This is all imaginary here. This is real. This is real here. Let's look at the imaginary part here. On this side, the imaginary part here is 8. What's the imaginary part on this side? The imaginary part is that there. Okay, so that gives us two equations. Actually, I'll keep those colours and do the equations. Let's do the real part first. Okay, the real part is 2x plus 3 must be equal to -1 there. And so all we do is solve that equation. And so we move that 3 to that, so 2x is equal to -4. Therefore, x equals -2. Easy. Let's go back and do the imaginary parts, and also the imaginary parts. On this side we have 8 must be equal to the imaginary part on this side, so that's 2 minus 3y. Therefore, 6 is equal to -3y. Therefore, y is equal to -2. Also, that's turn up to there. So there you go. So equality. If you've got two complex numbers which are equal, you just make the real part equal to the imaginary part. With adding, let's just do adding. All you do is you add the two parts together. So let's just going to go really quickly through this. An example of this: 2 minus 7i. If we add that to -7 plus 6i, all you do is you add the real and imaginary parts together. So let's look at the real parts here. just again, the real part is that 2 and this negative 7. So let's have a look at that. So 2 plus negative 7, that's our real part. So I'll just do each part. No, just confuse everyone. And then the other parts you got a negative 7i here, and you've got a positive 6i there. So let's just write that down. So plus negative 7 plus 6i. So that's our imaginary parts. So if we add them together, we get 2 plus negative 7 is negative 5. Add the imaginary parts together, negative 7 plus 6 is negative 1i. So we're just adding and subtracting the parts together, which is negative 5 minus I. So that's how you add two complex numbers together. Let's just do a 1 plus I. What happens if we subtract? I can just make a bit more space on my desk here. 1 plus I, what happens if we subtract two complex numbers? Okay, let's have a look at this. Again, do it part by part. Let's do the real parts first. 1 minus negative 2. 1 minus negative 2 is 1 plus 2, so that's 3. Let's look at the imaginary parts. We've got I minus I, which is 0i. And because we've got 0i, that does not exist, and we just end up with 3. So we end up with a real answer to these two. So here we've got a complex number minus a complex number, and we end up with a real number there. So subtracting, just make sure you put the brackets in there. Really important to put brackets in so that the negative goes to both parts of that complex number. And finally, just let's look at some multiplying. So let's have a look at multiplying complex numbers. So again, I'm just going to do an example. I'll give the notes in class. But an example of multiplying, if we have a complex number negative 2 plus 6i, then it's exactly like your algebra before. This 3 gets multiplied by each part in here. Okay, so 3 times negative 2, negative 6. 3 times 6, 18. So you end up with negative 6 plus 18i. Very simple. So what would negative root 3 times root 2 minus 6i be? Again, just multiply it out. What's root 3, negative root 3 times root 2 is negative root 6. What's negative root 3 times negative root c? That's positive 6 root 3i. And so that would be your answer to that. So that's just an introduction to complex numbers, how to write them out, how to find real imaginary parts, what to do when they're equals, how to add, how to subtract, and how to multiply.